Hello everyone. I welcome you all to my online lecture. Today we'll be discussing centrifugal compressors. As you all know, the compressors are actually classified into two types. They're classified into reciprocating compressors and centrifugal compressors based on the way in which they work. We'll be studying centrifugal compressors today. It will be working on centrifugal action. It is a rotodynamic type of compressor in which the required pressure rise takes place due to continuous conversion of angular momentum imparted on the air by high speed impeller into static pressure. Now, before I explain the working, I'll explain the parts of a centrifugal compressor. Now, a centrifugal compressor mainly consists of three parts. They are impeller, a diffuser, then a casing, a volute casing in which these two parts are housed. Now the working is pretty similar to that of a centrifugal pump. Now impeller is a rotating disc with a series of curved blades on its surface or on its circumference. And along the circumference of the impeller blades there will be a set of diffuser blades. As you can see, the shape of the diffuser blades are like this. They are diverging blades. So as air flows through it, the pressure decreases. The pressure increases as its velocity decreases. I'll explain that later. Now I'll explain its working. Now the whole thing is fitted inside a casing, right? Now listen very carefully. The whole casing will be filled with air. This whole casing will be filled with air. Now what happens is, since it is already filled with air, when it rotates, the air will be thrown outwards in this way. As a result of which, a vacuum will be created in the sender, and this will suck in the air from the outside, and the air entered will flow radially through the impeller blades. And what happens is, due to this high centrifugal force produced by the rotation of impeller, the air moves radially outward direction through the impeller vanes. When the air flows through it, it causes a rise in its static pressure because of the increase in momentum of air, and there will be also increase in its temperature and velocity. Now, with this high static pressure and increase in velocity, the air will move into the diffuser blades as shown in the figure. Now when air moves into the diffuser blade, what happens is, since they are diverging shape, now what happens when the area increases? According to continuity equation, when area increases, the velocity decreases. So this decrease in velocity is made up by increase in pressure. So when it goes out of the diffuser blades, the air will have a very high pressure in the range of 4 to 6 pressure ratio. It will have a pressure ratio of 4 to 6. Now this is the working of a centrifugal air compressor. Now this graph actually shows the variation of pressure in a centrifugal compressor and variation of velocity of air passing through the compressor. Clear? So I hope you have clearly understood the working of a centrifugal compressor. As you can see, the pressure increases to P3, and this shows the pressure rise in the impeller, and it will again increase in the diffuser area. In the case of velocity, in the impeller the velocity increases, and in the diffuser the velocity decreases, which I have explained before. So I hope you have clearly understood the working. So next is the velocity diagram and theory of operation of a centrifugal compressor. Now everybody please look into the figure. As you can see, there are two velocity triangles, right? One at the inlet and one at the outlet. Now this curve actually shows the impeller blade, and this curve shows the diffuser blade. I'll explain the inlet triangle first. You have the absolute velocity V1. U1 is the velocity, mean velocity of the blade, and the relative velocity of V1 and U1 is VR1. So absolute velocity V1. This velocity V1 has two components. Horizontal component VW1, which is called as velocity of whirl, WHIRL, and VF1 is the vertical component. It is called as velocity of flow. Now, there are two angles, alpha and theta. Alpha is the angle made by V1 with U1. It is called as guide vane angle or guide blade angle. And theta is called as impeller blade angle or just simply vane angle. Similarly, we have a velocity triangle at the top also, at the outlet also. In the inlet triangle, since alpha is equal to 90°, the velocity, horizontal component will be 0 and V1 will be equal to VF1. Just keep that in mind. I'll explain the outlet triangle now. V2 is the absolute velocity. You have the U2 velocity, mean velocity of the blade, and this one is the relative velocity. And beta 5 are the angles here. Beta is the guide blade angle in the outlet made by V2 with U2, and 5 is the vane angle which is made by VR2 with U2. Clear? And these are the tangent at the inlet tip, and this is the tangent at the outlet tip. Now this VR1 and VR2 will be parallel to the diffuser blade. Clear?